Okay guys, we just got done writing the equation for parabola given the vertex at 0, 0 and either the directrix or focus. Remember, we called P basically the distance from the vertex to either the focus or the directrix. It's just the distance between them. So if the vertex was at 0, 0 and the directrix was at 5, y equals 5, then we're using essentially 5 for P because those two things are 5 units apart, right? From 0, 0 to 5, that's a distance of 5 units. And that's essentially what P was. But the catch was sometimes we had to use a negative 5, sometimes we had to use a positive 5. We talked about a little bit as to when to use either or, when you keep the sign, when you don't. Now we're going to keep going with that, so we're going to practice a little more, but we're going to do it with the vertex not at 0, 0. And in that case, you know, there's a little bit more information we need to keep up with. Alright, so here it is. Again, for a horizontal parabola, this is our vertex form. It's x on the left side, that's how you can sort of tell it's horizontal. But now we actually have the h and k. In the last video, we didn't have h or k because we were starting at 0, 0. But now we're going to be in some random place. We're not going to be at 0, 0, the vertex. Alright, but you still know your vertex form, okay? H and K is still the vertex. P is going to be the key piece of information here that we need. How far away is that vertex from the focus or directrix? And the vertical one's pretty much the same thing, except it's y equals, you know, you still have H and K as your vertex. Now, helpful information here is the focus and directrix. So, the focus, if we know what P is, we're just going to add that number to H, or whatever the X value is in the vertex. So let's identify what the vertex is, and let's identify the distance P, okay? And then we can use sort of this information by adding it to that X value to find out where the focus is going to be, okay? But again, at the end of the day, our problems are going to be, let's write the equation for the line. But we have to keep this information in mind. For a vertical parabola, we're going to add P to the y value. Because remember, vertical is the y equals. So we're going to be adding that P value, which again, P is the distance, okay, between the vertex and focus, or vertex and directrix. Adding that distance to the y value. Whereas horizontal, we're adding it to the x value. So horizontal is for x equals, vertical is for y equals. Alright. So let's sort of get into it here. Find the vertex, the value of P, the axis of symmetry. I don't really care about that right now, but I guess we'll find it. The focus and the directrix of the parabola. Alright, so apparently I was wrong a bit. I thought we were going to write the equations of the lines, but we're given the equation of the line, and all I got to do is identify all this key bit of information. Let me go ahead and put it somewhere on the side here. The vertex. What else do we need? The value of P, so I'll find the value of P. Axis of symmetry, S, I'm just going to abbreviate it to S. The focus, oh man, I'm running out of room. There's a lot of things I need to find here. And the directrix. Alright, I'm sure we can do this on a graphic calculator. I'll probably do that in a different video if I find the time. But anyway, let's go ahead and knock these out one at a time. Then graph. Oh, of course, once the graph. I'll probably skip that portion of it. I'm sure it's on the slide anyway. But yeah, we know all these pieces of information, all 5 of these, then we can certainly graph it. Alright, so what is the vertex? So we already did this back in the previous one. So this is the K value. This K value is equal to -3, and this is my H value. It's a positive 2. Remember we discussed those signs are opposite in those positions. And if you just are confused as to why that is, go back and the formula here is y minus k equals a x minus h squared. So where you see a minus sign in the equation means that whatever number is in those positions, which in this case is 3 and this minus 2, the minus sign is indicating to you that you need to take the opposite of the sign that you see. So because this is a +3, this formula tells me I need to do the opposite of that and call it -3. Same thing for the h. Because it looks like a -2, the formula says, hey, you need to do the opposite of that value, so that's why I'm using a +2. So go back and look at your formulas and just look for where it's a minus sign, because that minus sign is telling you when you have to change it, the sign from either positive to negative or negative to positive, or if you leave the sign the same. But anyway, our vertex is at 2, negative 3. So that's just given to us in the equation. All this stuff is given to us in the equation. Now P, where was P yesterday? Remember, P, if you look back here, P is right here in the denominator. It's 4 times P. Gets you the number in the denominator. So that must mean 8. 8. This was 4 times P. So what is P? If 4 times something is 8, what is P? Well, P's got to be 2. P equals 2. Because 4 times 2 would be 8, and thus how we got the 1/8. So that's how you're going to find P. Basically, keep it short and sweet. Take whatever number is underneath that denominator and set it equal to 4P, and just divide and solve for P. Okay? Every single time, take whatever number's in there and set it equal to 4P, and you'll find your P. All right. The parameter, the distance that you're looking for. Now the axis symmetry, we talked about this way back in the day, but the axis symmetry is the same as the x value in our vertex. Well, that's the case for a vertical parabola at least. This is a vertical parabola because it is y on the left side, x in parentheses. So the axis symmetry is going to be x equals 2. Okay, because that's the x value in the vertex, and that's always the same as the x value in the vertex for vertical parabolas anyway. The focus, all right, now here's the thing. We have a formula for that as well. It's back on this previous slide. Focus is, for vertical parabolas, this one over here, the focus is h and then k plus p. All right, so I have h was 2, right? And then k was negative 3. But I need to add 2 to it because that was p. So remember, this is h and then k plus p. That's a little, somewhat of a formula for you to find your focus, but let's simplify that. So that's how we're going to do it. We need to add 2 basically to negative 3. So that's going to become, what's negative 3 plus 2? Negative 1. So our focus is 2, negative 1. Now, the Directrix also has a formula. It's y equals k minus p. All right, so y equals k minus p. K was negative 3, and p was 2. So k minus 2, which is going to be negative 5. So our Directrix is y equals negative 5. So remember, pretty much all of these have some sort of formula. So the focus formula was, it's not really a formula, but for vertical parabolas, it's h and k plus p. We already found h and k, right? That's the vertex. We already found p, so we're just going to use this mini little formula to find the focus. The Directrix, very similar. For a vertical parabola, it's y equals k minus p. So again, I already knew what k and p was, so I just plugged them in. And the y equals is supposed to be there. Again, that's part of our answer, the y equals. All right, so there's all our information. Okay, I really didn't do hardly much math at all. I just had to kind of dissect the equation. So let's try doing this another time. You can see all the answers kind of showing up here and how we got everything again. So if you want to pause the screen and look at it one more time, you certainly can. There's the graph of it as well. All the features we just talked about are plotted there. The y equals negative 5, the Directrix. We talked about the vertex. I think these are going by 2, by the way, so that's 2, negative 3. Anyway, it's all there. But let's go ahead, let's just keep trying some more problems here. Find the vertex. Find the value of p. Find the axis of symmetry. The focus, so it's asking for all the same information in Directrix. Alright. Now, first and foremost, I want to discuss whether this is a vertical parabola or horizontal parabola. Alright. I see it's x minus 1. So x is on the left side, I have y inside my parentheses. This is a horizontal parabola. Alright, probably didn't have to write it all out, but there it is. Horizontal parabola. So the information we're going to use is back on this previous slide, which should be in your notes somewhere. We're going to be using all this stuff for the horizontal parabola. Everything you see here on the right. We've got this is our vertex form. We're going to use this little formula for our focus and this little formula for the directrix. Okay? So h plus p, k, and x equals h minus p. We're going to use those to find those at the end of the problem. All right. So the vertex, I need h and k first and foremost. So here's h. H is a positive 1. And here's k. K is a positive 3. I know that this is k and this is h because remember k is associated with y. So if I see a number next to y, I know that's going to be the k value. Same thing for h. X is associated with h. So if I see the number next to x, I understand that that's h. And both of these signs are opposite for the exact same reason I said in the last problem that those signs are opposite. But our vertex here is a point 1, 3. Okay, h is 1, k is 3. Now p. Remember, the p is sitting in here. This is 4p. 4p is equal to 12. Okay? So 4 times what got us to 12? Right? I mean, you can solve it. You can divide it by 4 if you need to. But you'll see at the end of the day that p is equal to 3. So that must mean our vertex, the focus is 3 units away. The directrix is 3 units away. That's what the p stands for. The axisymmetry. Now, this is a little bit different. Because this is a horizontal parabola, we haven't actually discussed the axisymmetry before in a horizontal parabola, but it's very similar to vertical parabolas, except, for vertical parabolas, it was always the same as the x value. But for horizontal parabolas, it's going to be the same for the y value. So y equals 3 is the axis of symmetry here. And you'll see that when I graph it. I'll show you a little bit more about that. All right? But just kind of keep that in mind. For horizontal parabolas, it's the y value of the vertex, not the x. Okay? That's the only difference between them. The focus. So remember, what was the formula it gave us? It was something like h plus p k. If I remember correctly, let me go back a couple slides. Oops. H plus p and then k. So. And then the directrix was x equals h minus p. This is for the focus, and then directrix was x equals h minus p. But hopefully I remember that correctly. Yeah, I did. All right, the focus. So I already know what h is, right? It's 1, but I need to add the p value to it, which is 3. And then the k value is 3. So really this point is going to be 4, 3. That's the focus right there. That's all there is to it. The directrix is x equals, I already know h. H is 1 minus p. I know p is 3, so x equals -2. And that's your directrix right there. So got all the information that we were required to find. All right. And it's based on everything we already kind of learned, everything we already know, which is good. Very helpful. Well, let me see the graph, and I'll talk more about why the axis symmetry is y equals. So, because it's a horizontal parabola, right, it's opening up to the right side here, which means the vertex of, the axis of symmetry goes, it's still similar. If you kind of tilt your head a little bit, you can still see it. The axis symmetry goes sideways, just like the parabola goes sideways. Because it goes sideways, right, we're actually hitting the y-axis. Right? And where are we hitting the y-axis here? We're hitting it at y equals 3. So that's why our axis symmetry is a y equals 3 instead of the x value as before. So keep that in mind. It's one thing that's kind of new. You already know the axis of symmetry for a vertical parabola is the same as the x value of the vertex. And the axis symmetry for a horizontal parabola is the y value of the vertex. Okay. I think that's going to cover it. I mean, you can do this problem if you want to. I think you generally get the idea. I'll show the answers though, so if you can check your work if you want to just practice. All right, but I'll leave you with that, and I'll see you later.